All right, so today we're going to be doing part two. Um, we're going to be talking about the formation of soil. As you recall, yesterday we talked about how weathering breaks down rocks. And again, you should be writing this down in your notes, having this in your notebook, so that you're keeping up with the concepts that we're teaching here. Just a quick review from yesterday. We said that, rocks that are broken down chemically or physically will produce sediment. So when rocks weather, they are broken down into smaller fragments. We call those sediment. Now, generally speaking, sediment sizes, when it comes to soil, we're going to really only look at 3 sediment sizes. And I know there, of course, could be sediment from, gravel, pebble, cobble, things of that nature. But we're really looking at sand, silt, and clay. Okay. So what happens when rocks weather and they break down? Well, they form those sediment, and the result of that is soil formation. So by definition, soil is the mixture of rock fragments, mineral fragments, and organic matter. It's very important that you understand that organic matter has to be present for it to be considered a soil. Okay? If there's no organic matter, and remember, organic, the word organic, anytime we see that on my test, we see it on the SOL. Anytime I see organic, that means once living. So soil needs that. So we're going to get nutrients from once living things. Okay? So soil is the mixture of rock fragments, mineral fragments, and organic matter overlying the bedrock at Earth's surface. So what do we call this organic matter? Well, it's this black stuff right here. Okay? If you go out in the woods and, you go hiking, a lot of times you will see a lot of organic matter laying on top of the soil. That's called the O horizon, or organic matter. Okay? I'm a big time deer hunter, and anytime I would deer hunt, I would go out, and let's say I wanted to go out and I was going to hunt from the ground. First thing I would do is rake back the leaves so that if I moved, I wouldn't create so much noise. Okay? Well, you've probably been in that situation as well. When you rake back the leaves, the thing that you see is this layer here called humus. And humus is the dark, decaying organic matter composed of dead leaves, twigs, or even dead animal remains. It kind of takes me back to the days of the Lion King. If you recall the Great Circle of Life, where Mufasa tells Simba it's part of the natural order that, when something dies, it decays, and it, adds nutrients to the ground. And of course, the antelope eat the grass, and we eat the antelope, is what he said. So the Great Circle of Life. I always like to kind of say that, because it gives you the picture of any dead organic matter is going to add nutrients to the soil. So even dead leaves and the twigs, and yes, even dead animal remains. So the type of soil that we end up with is going to determine by this acronym here, CORT. Okay? And it's a good way to kind of get an idea of what type of soil you're going to end up with. The type of soil that forms is determined by CORT. Some call it CLORT, but I always just take the L off there. And the C stands for climate. Just by understanding this, if I'm in a climate that has a lot of rainfall, that means the horizons. And remember, another name for horizons would be a layer. Okay? And you'll learn that here in just a moment. But the more rainfall that comes in, the thicker the layer is. Okay, so the type of soil that forms is determined by climate. Okay, so if I have a lot of rainfall, then I'm going to have thick layers. If I don't have a lot of rainfall, it's going to be a lot of sand and, not much of topsoil of any, and it's going to blow constantly, creating sandstorms in those arid climates. The next is going to be organic matter. Okay, again, how much is available? Am I in an area with a lot of rainfall? Because we know that water is the universal solvent, which means you cannot survive if you are organic and not have water. Okay, got to have water. Relief is, what is the slope of the land? Is it on a steep slope? Okay, is it on is it in the valley? If it's in the valley, it allows it to grow. And when I say grow, it allows it to pile up with more sediment and the possibility of organic matter growing there. So relief is one. Parent material. What type of bedrock was the beginning of it all? Okay? Because you'll see when we're talking about soil development, the type of rock that you have there is going to determine the characteristics of the soil. If I have limestone as the bedrock, the last thing I want to do is add lime as a fertilizer to my grass or my yard, because the pH balance will not be there. So you really need to know what type of parent material is there. And last but not least is time. How long has the soil been developing? Has it been developing for 10 years? Well, that's not much of soil, because a lot of times soil takes thousands of years to develop, especially if it's a healthy and fertile soil. Okay? So here are the stages of soil development, and what you'll have to do on my test, and you don't have to draw this or anything, I just want you to look at it and pay attention to how I teach this, okay? What you have to understand is this will not be in order here, okay? They will ask you to put it in order. So the beginning stage is always going to be bedrock. It is the first stage. And notice there's nothing but rain here. There's some cracks here, which is promoting, of course, weathering, which we've talked about. The next stage would be pioneer species begin to come in. Okay, and we call these pioneer species weeds. Okay, yellow goldenrod, thorns, just all these different types, stickers, all these different types of weeds coming in there. And what that does is those tiny root systems help break up the rock, but it's also adding organic matter. The next stage would be a development of a horizon. And remember, another name for horizon is layer. But here's just a top layer here, so that would be the next stage. For it to be what we considered a mature soil, or one that can grow crops, you need to have at least 3 horizons. You have the topsoil here, which is A. You have the subsoil here, which is B. And then you have the partial rock here, C. And of course, at the bottom of it all would be bedrock. So make sure that you understand this order that we have here, because on the test, you'll have to put it in order. So just to make sure that we know, we're always going to start with solid bedrock, and then we're going to end up with at least 3 horizons here. So what is a profile? Okay. Now, what you're going to do is you're going to divide every horizon up, okay? And I have this already drawn in one of your handouts, and so I just need you to, on this particular slide, just hang on there and listen, and then the next slide we'll start our drawing. Scientists divide soil into 4 horizons or layers, okay? Now, some of them add the leaf litter up here as the O horizon, which stands for organic, and that's fine. But really, it's the A horizon, which is topsoil. the B horizon, subsoil, C horizon, and then of course the bedrock. Now, you need to write this down. The A horizon. See how dark this is? Okay, this is characteristic of an abundance of organic matter. The A horizon is sometimes called the topsoil. It is characterized by being dark because it is loaded with humus. Now remember, we said that humus was leaf litter, it could be animal remains, it could be twigs, it can be all that organic matter that's added to the soil from trees or animals, okay? The part that you must understand is it's dark because it is from more of an organic material. It has a lot of organic material there. This is the most developed horizon, okay, the A horizon. So you want to draw this right here. You know, you can just block it out right here real quick, and you're going to have, you know, just a rectangle type shape here, and you're going to block them off. So the top, you would put topsoil, and you would put A, and then you would have this here, which would be subsoil, which is B, and then of course you have C down here, which is partially weathered rock. Okay, you want to draw that out, and at the bottom make sure you put that bedrock, and this is the parent rock that has been weathered. So in looking at this, the A horizon is the topsoil. Why is it so dark? Well, you should be saying it's dark because it has organic matter. And to be correct on saying this, and more correct would be it's loaded with humus. And remember, humus is organic matter. Now, as I go down, there's less organic matter. So look at the color here. As I go down, I'm in the subsoil, so why does it get lighter as I go down in color? That was on the SOL. You know, that's an SOL type question. Why does the soil get lighter as you go down? Well, the reason being is it has less humus, okay? And then the one horizon that mirrors, if not shares almost the same quality of the bedrock, would be the C horizon, okay? So the A horizon is the most developed. It's been there the longest. The B horizon is then next, but the least developed, of course, would be the C horizon. So what is leaching? When we think of leaching, you know, some nutrients will leach from the A horizon down into the C horizon. Well, leaching is going to occur because what happens is water, and you need to write this down, make sure you're writing this down. What happens is water comes from the rain, and as the rain infiltrates down through the soil, sometimes it carries nutrients. So if I'm in a climate that has a lot of rainfall, then the root systems of those trees are going to go down. The reason why, they're searching for more water, and they're also searching for leached nutrients. So in this area here in Southwest Virginia, we know that the trees here, most of the root systems go down because we get at least 26 inches of rain or more annually. Okay, so we have thick horizons. If I'm in the Great Desert out west, then those cactus are going to put their root systems closer to the surface because there's no water below the sand. So they spread out, and when the water does come in, it will actually enter the root system, and the cacti root system will bring that water back to the trunk. And that's why if you're ever in the desert, one place to find water is in the trunk of a cactus. It'd just be very difficult to find. So leaching is the process of washing nutrients from one horizon to another, and it's very common in areas that have a lot of rainfall, especially tropical rainforests.